All right, so what we're going to do is talk about graphing inequalities. So what we're going to do is shade. So we're going to shade. Just put that down there. We're going to shade. Our topic today is Common Core, and it's A-CED3. What does that say? Well, let's find out, okay? Common Core, what's the Common Core lesson, all right? So if I read it, give me a second to find it. And it is, here it is. ACED3 says represent constraints by equations or inequalities and by systems of equations or inequalities, okay? To interpret solutions. That's what we want to do today. So we're going to go ahead, and I'm going to paraphrase a little bit of this, but we're going to create, we're going to, let's see, we're going to represent, that's an R, represent inequalities and systems in inequalities, okay? I'll rewrite it. Represent inequalities and systems in inequalities, okay? I'll read it again. That's an R, bad looking R. Represent inequalities and systems in inequalities, okay? Now, inequalities are these Pac-Man symbols. We don't really call them Pac-Man symbols, but you know, the greater than or equal to, less than, okay? These are our inequalities. Now, when it says systems, that's where we may shade two graphs together, okay? So if you graph two or more graphs together, that's a system. So let's take a look at example 1. So example 1 says graph y is greater than or equal to 2/3 x minus 1. We're going to graph it just like we used to. Start at -1, right, on the y-intercept. Then we're going to apply our slope up 2 over 3, up 2 over 3. Okay. Now, we have to be careful. What we want to do is graph everything above this line and everybody's eyes up here real quick. See this little bar? That means equal to. So we want to equal the line itself. So we have a choice to either make a dashed line or a solid line. We want a solid line because of that little equal sign. So I go ahead and graph my line in, not as a dashed line, but as a solid line, okay? Now, there's a whole lot of points. Every point above the line, like for instance, this point is part of the answer. This point here is part of the answer. This point here is part of the answer. Even this point right in between in the middle is a decimal point, but it's part of the answer. So that's a lot of points. Every one of these points above the line will make a system that's greater than or equal to 2/3 x minus 1. Well, so what we do is we shade. By shading everything in that region, we're in a sense showing that all of these points are solutions, okay? And we're going to do one example. Let's pick the point, right here, which is at the point 3, 4. So I'm just going to show you how it works. So to check, and you do not have to check, but I just want to show you how it works, okay? So this point here I'm saying is in the solution. So if I pick the point 3, 4, I'm sorry, that's 4, 3. And there's lots of other points I could pick, but let me just pick that one. I'm saying that will work. So if I put the 3 in for y, so if I say 3 is greater than or equal to 2/3 times 4 minus 1, what I get is 8/3, and 8/3 is the same thing as 2 and 2/3. 2 and 2/3 minus 1 is the same thing as 1 and 1/3. So you get a thing that says 3 is greater than or equal to 1 and 1/3. Is that true? Is 3 greater than or equal to 1 and 1/3? Sure it is. And all of these points, any point you pick, if you plugged it into the original equation, would work. Now we don't need to do that. We don't need to do that because by shading, we've just shown all of these points. I mean, every one of these points will work. It will make sure that y is greater than 2/3 x minus 1. Okay, easy? So here's another way. Greater than is above the line, right? Less than is below the line. If it's raining, think of it as a lean-to. If it's raining, you want to get under it, you'd stand down here. That'd be less than, right? And the rain's going to come above. Okay, example 2. Now, first of all, in example 2, when I notice the sign, there's no little equal sign. So I know for sure I'm going to do a dashed line. Okay, it's got to be a dashed line because there's no little equal sign. So when I draw the actual line in, I'm going to make sure I get a dashed line. Okay, so, all right, I'm going to start at 5. 1, 2, 3, 4, 5 on the y-intercept. And then the slope of negative 2 over 1, so I'll go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And what I'm going to do is, instead of drawing a nice solid line, I'm not going to draw a nice solid line because I need to make a dashed line. So just make a dashed line look something like this, okay? Because it shows that it's going to equal everything less than the line, but not the line. Everything less than the line, but not the line. So make it a dashed line because it does not include the line, okay? Now what's less than that? Y is less than, needs to shade below it, right? So I'm going to shade the entire region below the line because that would make it less than, right? Hopefully you guys did this in algebra. Okay? Okay, example 3. So in example 3, we're going to have to solve for y because we have to have it to be y equals or y is greater than. So let's solve for y first, all right? So I'll bring over the 3x, and the way I bring over 3x, go minus 3x, right? I have to do that first. So I would have a 2y is greater than a 12 minus 3x, or minus 3x plus 12, same thing. Divide by 2, divide by 2, divide by 2. I can get then y is greater than 6 minus 3 halves x, okay? Okay, now I can graph it, but before I do anything, I know I'm going to make a dashed line. It does not have the little equal sign, right? It's a dashed line. So we'll start up at 6. That's my y-intercept. 1, 2, 3, 4, 5, 6. I'm going to apply my slope, which is a negative 3 halves. So I'm going to go down 3 over 2, down 3 over 2, down 1, 2, 3 over 1, 2, down 3 over 2, and so forth. So now again, we discussed the fact that it's going to be a dashed line because it does not have equal. So it doesn't include the line, but everything greater than the line. So just make my dashed line. And then I'm going to shade, so it says greater than, I'm going to shade everything above my line. Which is all of this, which is all of these points in here. How's that? So far so good? Thumbs up? Doing all right? Okay, example 4. Example 4 sure looks a lot like example 3 with one small thing. I'm going to, in the process, I'm going to have to divide by a negative 4, okay? I will. I'm going to have to eventually divide by negative 4. And when I divide by a negative, I'm going to flip, I will flip the sign. So I'm going to flip the sign, but not until I divide by negative 4, okay? In the process of solving this, so let me put it back down here so I have room for it. I'll put 3x minus 4y is less than or equal to 12. So let's solve it like we always do. Let's go minus 3x, because I want to get y by itself. I'll have a negative 4y is less than or equal to 12 minus 3x, right? And now here comes the step where I'm going to divide by the negative. So the next step is divide by negative 4, which will turn the sign. So I'll divide by negative 4. And when I divide by the negative, I turn the sign. So I divide it by a negative number. So I change it from less than or equal to greater than or equal to. So just change the sign. So I have y is greater than or equal to a negative 3 plus a 3/4 x. All right, now that I need to graph. Okay, I know I'm going to do a solid line. Solid line because it's got the little equal sign, right? Solid line, it's got the little equal sign to it. So let's start at negative 3. 1, 2, 3. And I'm going to apply my slope. I'm going to go up 3 over 4. Up 3 over 4. solid line because it has equal sign in it, right? How's my pacing? Am I okay? Am I going too fast? Am I good? And since it says greater than, I want everything above my line. I'm going to shade everything above my line. So I'm going to shade all of this. Okay, how am I doing? Okay, turn the page. All right. Example 5. Y is less than 4. Okay, now, hopefully you remember that if I had to graph the line y equals 4, if I had to graph y equals 4, it would just be a horizontal line, straight line, horizontal line. Everybody agree with that?
Yep.
So we're going to do the same thing. We're going to make a horizontal line, but it's going to be dashed. It has to be dashed. It has to be dashed because there's no little equal sign. But I'm still going to go to 4 and put in, my line. So I'm going to go up at 4. I'm going to go 1, 2, 3, 4, dash line. Okay, how's that? Let's read it. It says y is less than, so shade below. Yep. Nice job, Dylan. Totally right. Shade below. I like that. All right, last one. So let's do the opposite. Let's figure out how to find an equation. So the first thing I notice is the sign. I know I'm everything less than, right? And I also see it's dashed. So I know for sure I'm going to have a y is less than. You guys agree with that? I mean, I don't know the equation. I'm going to make the equation, but it's certainly shaded below, so it's less than. It looks like it's dashed, right? It's kind of hard to see, but I think 1, 2, 3.
Staff, please excuse this interruption. We are ready for the GSA and the FCC LA Club. We're going to be meeting in front of the school. Once again,
Okay.
the GSA and the FCC LA, we're ready for you.
So we're going to start at 3. Okay. And then it looks like we go down maybe 3 and over. Boy, 1, 2, 3, 4, 5, 6. So I think we're going down 3 and over 6, right? It goes down 3 and over 6. It's hard to see through this, but definitely down 1, 2, 3 and over 6, which same thing as a negative 1/2. So how about a negative 1/2 x, and then it starts up 3, positive 3. How's that for an equation? All right, so homework for today, page 128. It's a lot of shading, but it's really pretty quick. Page 128, and you can see the problems, and we'll hit stop.